Hello, this is my week four, or discussion for stats. And the first thing that I am going to talk about is the context for my data that I have created. So this is my data right here, and it goes down as well. So you can see there's a lot. And so this is my data, which includes the values that go along with their context. So we were looking at 65 students in a stats class and seeing how each individual did on their exam or quiz one. And our descriptive statistics here is 65 because that's the amount of students that were in this class. And so as you can see, our data set is a straightforward way of organizing all the individual pieces of information, but it's not great at or it's not great for learning what the data has to communicate. So that's why we created the bar graph and the scatter plot, which I will get to in a moment. So for our two quantitative variables, which are the quiz and the exam one, um, for the quiz scores, we are looking at the overall score on quizzes 1 to 3, and that doesn't include the lowest one that was dropped. And I said that the quiz score is our explanatory variable. And then for our exam one score, this is the grade students received on the first exam, and this does not include extra credit points. And then the exam score is the response variable. So just to sum up everything, so we are looking at the students of a stats class that, or who were enrolled last semester at the University of Iowa, and we are looking at their quiz and exam scores. And the reason why we are looking at this is to see if there is a relationship between the quiz and exam score. So here are my two histograms. This is the quiz and the exam. And then I'll go down to my scatter plot. So the scatter plot, as you can see, shows a moderate uphill positive linear relationship. So with our two quantitative variables, we know that we have the quantitative variable condition, which is one of the conditions for regression. And then we also have a linear regression, which is right here, this line. And then we don't have too many outliers, so we could say that this data adequately meets the assumptions and conditions for linear regression. And then up here, or I guess over here first, I'll sum up the calculations I got. So for the quiz score, I got the mean as 82.1, and the standard deviation is 15.23. And for the exam one, I got 68.2, and then standard deviation is 13.61. So up here is our regression equation. And this wants to see if there is a relationship between the exam and quiz scores. So the predicted score in this equation is 30.86. And then I'll go down here. So our R is 0.51, and our R squared is 0.26, or 26%. Our slope is 0.46, and our intercept is 30.4. So for our R squared, which is 26%, this number or percentage gives us the fraction of the variability in exam scores and is accounted for by variation in the quiz scores. And then for our predicted max, I made another column that includes all the predicted max scores right over here, and then which gave me the residual as well. So for our residual standard deviation, I got 3.1, and that's just showing, or the residuals, standard deviation residual is saying what we actually got and what we predicted. And so it basically describes the standard deviation of points formed around a linear function and is an estimate of the accuracy of the dependent variable being measured. And then if we look at, if we look at student 5, or the student with an ID of 5, she got 80, or he or she got 87 on the quiz and 73 on the exam, for a total max score of 70 and a residual of 3. And then when I calculated their standard deviation residual, I got 0.21. And then I'll show you on this graph. So if we take this dot and we put it right here, this is where student 5 would be, and that would be for their score. So she got, let me make sure, I think she got 77 on the exam, or 87 on the exam. No, 77 on the exam, and then 73 on the, or sorry, I'll rephrase. 87 on the quiz, 73 on the exam. And as you can see, this is where she is. And then her residual again was 0.21, and that would be compared to 3.1 for the data, so it was lower than the data total. So that's it. Thanks.